In this video, I want to talk about the multiplication of complex numbers. So the first example that we're going to look at is the multiplication of just pure imaginary numbers, and then we'll work our way up to complex numbers in a plus bi form. So similar to the addition and subtraction of complex numbers, I can treat the I in these operations much like I treat a variable when I'm multiplying or adding or subtracting algebraic expressions. It's just that at the end, the I is going to be treated a little bit differently. So here we go. We're going to take 6 times negative 2, which those are the coefficients. So that makes negative 12, times I to the power of. So I have I cubed, I to the 11th, and I to the 8th. And whenever we're multiplying like bases, we will add these exponents. So 3 plus 11 is 14, plus 8 more is 22. All right, well now I have a higher power of I, it's I to the 22nd. So when I simplify that, I could rewrite that as I to the 20th times I squared. And remember, 20 is a multiple of 4, so that's a good thing for us. So that just becomes 1, and I squared is negative 1. So this becomes negative 12 times negative 1. So I to the 22nd is negative 1. So negative 12 times negative 1 will be positive 12. So for our first example, we multiplied 3 pure imaginary numbers, and we actually got a real number, 12. In this second multiplication example, I'm going to multiply a pure imaginary number by a complex number, a plus bi. All right, so this looks a lot like our distributive property, so let me go ahead and distribute. So 3i times 2 is 6i, and 3i times a negative 5i, well, we'll do the 3 times a negative 5 first and get negative 15, and I times I is I squared. But we know that I squared is negative 1, so I can rewrite that as 15 times negative 1. So our negative here and our negative here will cancel each other out. So I'll have 6i plus 15. But I can't leave my answer in this form. I need to have it written in a plus bi form, where the real part comes first and the imaginary part comes second. So I'm going to flip the order of these, and I'm going to say 15 plus 6i, and that will be the product when I multiply 3i by 2 minus 5i. In this third example, I'm going to multiply the complex number 3 minus 4i by 1 plus 5i. And it kind of almost looks like I have a binomial times a binomial because of this I right there. Well, the approach that we're going to take is no different. I'm going to take this 3 and distribute him, and then the negative 4 and distribute him as well. So I'll have 4 terms, and then I'm going to simplify them accordingly. So 3 times 1 is 3. 3 times a positive 5i is plus 15i. Negative 4i times 1 is minus 4i. And finally, negative 4i times positive 5i will be negative 20i squared. And again, this I squared I know is negative 1, so it's just going to change the sign, and this 20 goes from negative to positive. So now I have some real parts that I can combine. 3 plus 20 is 23. And then I have the imaginary parts I can combine. So 15i minus 4i will be positive 11i. And I notice this is written in a plus bi form, which is standard form for a complex number. So I know that I'm done. So 23 plus 11i is the product of these two complex numbers. In this fourth and final example for multiplication of complex numbers, I'm going to multiply these 3 complex numbers together. Well, I notice that 2 minus 3i and 2 plus 3i are kind of complex conjugates, which means they're the same exact numbers except the sign in the middle is different. It also looks like, if you're considering algebraic expressions, the difference of squares. So instead of multiplying these two first and taking that product times this one, I'm going to change the order, and with complex numbers, multiplication is commutative, so I can change the order around. So 2 minus 3i times 2 plus 3i, and then 3 minus 2i. And I've just changed the order of those two complex numbers. And I'm going to show you why we did that. So when I just multiply these first, I'm going to distribute, and distribute. So 2 times 2 is 4, plus 6i, minus 6i, minus 9i squared. So two things here. The 6 i's cancel, which is really nice. And my I squared is negative 1, so it will change this 9 from a negative to a positive. So 4 plus 9 is 13. So instead of multiplying like the first two here and getting a complex number then to multiply by another complex number, I noticed the relationship, I changed the order because I saw we had difference of squares or complex conjugates, and when I multiplied those I actually got a real number. So now multiplying that by our final complex number 3 minus 2i is a simple distribution. So 39 minus 26i will be this final complex number when I multiply these three together.